Well, greetings once again. It's Professor Kelly, and I'm ready to go over the homework that I signed last night, which was group work 4. So if you would scare that sheet up, we'll take a look at what the answers are, hopefully, to these questions, assuming I don't mess them up. So you have to keep an eye on me to make sure. We're to write, for problem number 1, 683 as the sum of non-consecutive Fibonacci numbers. All right, in order to do that, I simply write down 683, and I ask myself, what Fibonacci number is closest to 683, but just a little smaller? And that, of course, is 610. So I put here 610. And then I have to write how much I missed it by. So back here is my favorite calculator, 683, and I'm going to subtract 610 from it. And when I do, I get 73. If 73 is a Fibonacci number, I am finished with this problem. Unfortunately, 73 is not a Fibonacci number, so I must continue. 683 equals 610 plus, what's the closest number to it that's smaller? It's 55. And how much am I missing 73 by? Well, if I take 73 and subtract 55, I get 18. All right, well, is 18 a Fibonacci number? Unfortunately not. So I go back, 683 equals 610 plus 55 plus, it appears the closest Fibonacci number that's smaller is 13. And I can see in my head that 13 misses 18 by 5. Okay, and 5 is a Fibonacci number, so I am finished. So 683 written as the sum of non-consecutive Fibonacci numbers is shown here. 610 plus 55 plus 13 plus 5. All right, let's go to the next problem. Problem number 2. We are to write this number as a sum of non-consecutive Luca numbers. Okay, so same process. I start with the 286. Okay, and I look for the smallest, or excuse me, the largest Luca number that is smaller than 286. And that is 199, right? And what do I have to add to 199? Well, I believe it's 87, right? 87, now let's make sure, 199 plus 87 is 286. Well, I look on my chart and I look to see if 87 is a Luca number. And of course, 87 is not a Luca number, so I must keep going. 286 equals 199 plus the closest Luca to 87 that is smaller than it is 76. All right. How much do I miss 87 by? It looks like it's 11. All right. 11 and 76 is 87. If 11 is a Luca number, I am finished. 11 is not a Luca number, so I'm not finished. So I go back. 286 equals 199 plus 76 plus, what's the closest Luca number to 11 that's smaller? All right. Well, wait a minute. Hold on. 11 is a Luca number. I was looking at the Fibonacci table, wasn't I? So guess what? I was done in the step before, wasn't I? Okay. Don't make the mistake I just made of going to the wrong table. So it's 199 plus 76 plus 11. That is the sum of, obviously, non-consecutive Luca numbers, which add up to it. And notice if you circle them on the table, 199, 76, and 11 are non-consecutive. They are not next to each other. And recall, if I go back to the first problem I was asking you to do. The 5, the 13, the 55, and the 610 are also not consecutive. They are non-consecutive numbers on the table. So we're good shape. All right. Well, I almost blew that one, didn't I? All right. Well, let's go on. There's a second problem down here towards the bottom, I believe. It says to prove that 145 is not a perfect number. Okay. To do this, I must obtain all the factors of 145. And remember, I look for the partner of each one. Well, 1 and 145 are partners of each other, but I'm not allowed to use 145. Remember, for this number to be perfect, I have to be able to add all of the factors together that would be able to divide evenly into 145, except for 145. And if they all add up to 145, I know the number is perfect. All right, but I'm going to prove that it isn't. Well, I know 2 won't go into 145. I don't believe 3 will go into 145. 4, I'm pretty sure won't go into 145, but I know 5 will. So if I take 145 divided by 5, I obtain, 145 divided by 5 would give me 29. So 5 and 29 are also factors of 145. Okay, well, I have to try other numbers. I've got to keep going because I've got to at least keep going until I get to 28 anyway, to see if there's any other numbers that will divide into 145. So I look at 6, 145 divided by 6, 145 divided by 6 won't work. It comes out a decimal. 145 divided by 7 gives me a decimal. 145 divided by 8 gives me a decimal. 145 divided by 9 gives me a decimal. All right. 10 won't go into it, I'm sure. 145 divided by 11 will also give me a decimal. 12 will give me a decimal, I'm sure. 145 divided by 12. Nope, that doesn't work either. 145 divided by 13. Nope, no good. 14. Nope, no good. I'm sure 15 won't work either. Okay, 15 doesn't work. 16 doesn't work. 17 doesn't work. Okay, 18 doesn't work. Okay, 145 divided by 18 will not work. Close, but doesn't work out too well. So I'm up to 18. Let's go to 19. Okay, 145. Whoop, not 148. 145 divided by 19 won't work. So I'm sure 20 doesn't go in. I doubt 21 goes in. 45 divided by 21. Nope. 22 I'm sure won't work. I'll just double check it. Nope. 23 I'm sure won't work. Divided by 23. No, it doesn't work either. 24 isn't going to work. Double check it. Nope. 25. Nope. Close, but no cigar. 26 doesn't work. 27 doesn't work. And 28 doesn't work. So guess what? If I take all the factors, all right, of 145 and I add them together, I'm certainly going to miss out on 145, right? This is 34. This adds up to 35. So 35 ain't equal to 145. So therefore, it ain't perfect. Q, E, D. I've done enough. Okay, very good. Well, let's go to problem number 4. A fairly tall building on a side street in Buffalo is 349 feet tall. How many times would you have to fold an extremely large piece of paper in half to just barely have folded the sheets, so in half to just barely have the folded sheet, surpass the height of the building? And by how many thicknesses of folded paper would you surpass the building's height? So I not only want you to figure out how many folds you need, right? But I also want you to figure out how many thicknesses of paper you surpass it by, okay? Well, let's see, 349 feet. How many pieces of paper is that? How many pieces of paper thick would that be? Well, let's see, 349 feet. I got to start with that using dimensional analysis. I want to change it down to inches, right? To get rid of feet, it must go on the bottom. For every 1 foot, there are 12 inches. We know that. Cross out feet. This computation would give me the answer in inches, but I want it in sheets of paper thick, right? So let's see. For every 1 inch, which would have to go on the bottom, so inches would cancel, there are 250 sheets of thickness of paper. So I will do 349 times 12 times 250. And when I do that, I get, looks like 1,047,000 sheets. 1,047,000 sheets. Now, how many folds would I have to do of a piece of paper to either get that exactly that thickness or just surpass it? Well, let's see. Let's try 2 to the 10th. Let's see what that gives us. 2 to the 10th. Now I have to switch calculators here. So I'm going over here to grab this one, and I turn it on and I clear it. 2 caret 10. Remember, you hit the caret key. It's 1,024. We're way low. So let's try maybe 2 to the 15th. 2 caret 15. That's 32,768. Now maybe we'll try 17. Let's just try that. So let's do 2 caret 17. When I do that, I get 131,000. So that's not going to do it either. So I got to keep going up. Let's try 2 to the 19th, just see what that does. So remember, it doubles every time you go up by a power of 1, right? So I'm going to do 2 to the 19th, caret 19, enter, 524,000. Hey, that's about half of that, right? 524,000. So maybe 20 is the number we're looking for. Let's try it and see, all right? So I'm going to do, and you should try this on your calculator if you didn't do this last night, we should do 2 caret 20. Ooh, I got a number pretty darn close, it looks like. All right, so if I do 2 to the 20th power, I'm doing this by trial and error, right, to find the answer, I get 1,048,576 sheets of thickness, right? Boy, that's awful close, isn't it? So to answer the question, by how many thicknesses of folded paper would you surpass the building's height? All I need to do is subtract these, right? So if I take 1,047,000 and I subtract it from that figure, right? I get 576 here. I miss it by, or I'm over by 1,576 sheets of thickness. Now that you have seen this problem, you can see that it wasn't really that difficult, right? All you had to do was first find out the number of sheets thick it would be, figure out what power of 2 beats it, just barely beats it, and all I had to do was subtract the two figures to obtain the final answer. So there are the answers for the homework sheet called Group Work 4, okay? Well, let's go on today now into some little bit harder stuff, okay? So let's take a look at this particular problem. Now, this is on a sheet called Group Work 6. I have sent you Group Work 6, so if you've printed it, you can fill it out kind of as we go here, and hopefully you can come up with some answers. But I'm going to tell you right now, on the back of this sheet, Group Work 6, is a very, very hard extra credit problem. And if you are able to solve the extra credit problem, okay, I will give you 10 points of bonus that I'll just add into your grade, okay? So that's a little bit of a challenge. We'll begin to set that problem up here in a few minutes, and you'll be able to see how you can maybe earn the 10 points. If you get the right answer, I'll probably even give you more points. But if you even try it and give it a good shot, I'll give you 10 points, okay, of extra credit. All right, so here we go, all right? So let's go here. This problem says, write the first 8 numbers in the sequence where the nth term of the sequence is given, all right? So, all right, let's see. What do you want to start at? Well, if we start at n equals 1, okay, we would get the same answer as we would get probably for when n is equal to 2. So why don't we start at n equals 3, okay? So n equals 3. All right, if n equals 3, I'm going to add Fibonacci number 3 to Fibonacci number 5. All right? Now, you can't add the subscripts. It's not going to be Fibonacci number 8. Okay, you know that. Okay, well, let's see. That would be Fibonacci number 3 is what? Fibonacci number 3 is a 4. Fibonacci number 5 is a 5. All right? And when I get that answer, excuse me, I just got the Luca number, didn't I? Let me try that again. Fibonacci number 3 is a 2. Sorry about that. Is a 2. Fibonacci number 5 is a 5. And notice I got the answer 7. Okay? Yeah. Gosh. 7 happens to be a Luca number. Oh, well, let's see if that happens again. Let's try it for n equals 4. All right, so that'll be f sub 4 I will add to f sub what? 6. F4 is a 3, right? I add to it F6, which is an 8, and I get 11. Gosh, 11's another Luca number. Let's try it for n equals 5. Okay? For n equals 5, let's see, that would be F5 plus F7, right? What is F5? Fibonacci number 5 is a 5. Fibonacci number 7 is a 13. And notice I got an 18, which is also a Luca number. Now, what Luca number is 18? It's Luca number 7, isn't it? What Luca number is the number 11, right? It is what? Luca number 6. What is the number 7 in the Luca table? What Luca number is it? It's Luca 5. So look here. When I added Fibonacci 3 to Fibonacci in position 5, I got the Luca number in position 5. When I added the Fibonacci number in position 4 to the Fibonacci number in position 6, I got what? The Luca number in the 6th position. And what happened over here? I got the what? The 7th Luca number. Now, if I were going to write this in a general formula, I think I might have asked you to do that. It says by examining the sequence of numbers in part A, give a general formula. So if I'm using a particular value of n, if I add f sub n and f sub n plus 2, what do I get? Well, you know I get a Luca number, but what's the subscript I'm going to write? I'll notice here, in the first one, I started with n as 3. I used 5 here, and I got 5, which is 2 more, right? So can you see that this answer would be Luca number n plus 2. So that general formula right there explains what happens when you add those Fibonacci numbers together in the way it's explained, okay? Now, I'm going to tell you right now, on your first test, I'm not going to ask you to discover a pattern like this, all right, and come up with a general formula. But when you take the final exam, I am going to give you a problem where I ask you to determine a general formula like this, or where you have to explain it in your own words, what happens. And what you could have explained here is what? You obtain each time a Luca number that has the same position as the second Fibonacci number we were adding together, okay? I would accept that as a correct answer also. But I'm hoping you can learn how to do or feel comfortable with how to get the general formulas. That wasn't so bad, right? Okay, that wasn't so bad. Okay, now, as you can see here, I have done all this work down here on this particular sheet that I've shown you. It's all set, and so we should be able to go on to the next problem. All right, let's go on. Okay, that one is the one I don't do anymore. Now, this is the extra credit question, and this bugger is hard, okay? I'm going to at least start you out on it, okay, so that we can give it a shot, okay? So here we go, all right? It says, by experimenting with numerous examples in search of a pattern, determine a formula for L sub n minus 1 plus L sub n plus 2. That is a formula for the sum of a Luca number 1 position before a given Luca and a Luca number 2 positions after the original Luca number. Note the answer will not be a Luca number. But guess what? Probably has something to do with Fibonacci numbers, I'm thinking, right? But I'm not going there. So it's going to be impractical to start this at n equals 1, right? Because we want Luca number 0 for L sub n minus 1. So I'm probably going to have to start with n equals, well, I don't want to start with n equals 2 because I'm going to maybe end up with something weird. So let's start at n equals 3, and let's see if we can get a pattern going here. All right, so what is L sub n minus 1 if n is 3? It is Luca 2, right? And what am I going to add to it? The number that's after the third position, right? And after the third position, 2 positions up is Luca number 5, which is a 7. Luca 2 is a 1. If I add those 2 together, notice I get 8. 8 is a Fibonacci number. Well, let's go on. Let's try some more. Let's do it for n equals 4. If n is equal to 4, okay, the first Luca number I'm going to do is Luca 3, right? Because I'm doing n minus 1, right? The next Luca number is 2 past that. So 2 past that would be Luca number 6. So this will be Luca 3, which is 3, plus Luca 6, which is 11, which gives me 14. Now that's not a Fibonacci number, right? Let's try it for n equals 5. Okay, so that'll be what? Luca 4, I do Ln minus 1, and Ln plus 2, so plus Luca 7, right? Well, Luca 4 is a 4, right? Luca 7 is an 18, and when I add those together, I get 22. And you'll notice that 22 is not a Fibonacci number. But notice, I'm developing another series. Look, if I add 8 and 14 together, I get 22. So you're actually developing another series of numbers that is produced the same way the Fibonacci's and Lucas are. You add the two previous to get the next. Let's try n equals 6. I'm running out of space here. If n equals 6, I'd be adding Luca 5 plus Luca 8, right? Luca 5 is a 7. Luca 8 is a 29. And I get 36. Of course, I would have known I should be getting 36 because if I add 14 and 22 together, I do get 36. Now, here's what I want you to do for extra credit. So let's go on here. It says, first write out the expression for the values 3, 4, 5, and 6, which I've done in 7, all right, which I already did. Let me see if there's anything else written here. No, there's not. Let me go to the next thing. All right. I guess it didn't go up. Hint. What do you notice about the number answers you got above? Do the numbers have as answers a form of any type of familiar pattern? Well, of course they do. It's the Fibonacci pattern, right? Okay, so we know that. Okay. Using a pattern you have discovered, predict the value of 19 plus 22. Luca 19 plus Luca 22. All right, you should be able to predict that using the information from above. Now, what? Give a general formula for this. It's equal to what? Now, I'm telling you, this problem will drive you crazy. But the hint I'm going to give you is, I believe it's the sum or difference of two Fibonacci numbers, okay? So give it a shot, give it a try. If you give it a shot and you show me what you've tried, I will give you 10 points bonus. If you get the answer correct, I will give you like 15 points of bonus, okay? So I want you to go ahead and try that out, okay? All right, now, the next problem that's on the back, and I didn't mention I'd gone to the back of the sheet, but I've gone to the back of the sheet, Group Work 6. I think you kind of figured that out. And so what I'd like you to do is take a look at this thing. Excuse the sip of coffee. Now, I want to write this as the sum of non-consecutive Fibonacci numbers, right? Okay, now, unfortunately, I have not, on my sheet, written a table, okay? Now, let me go back to and find the closest Fibonacci number to 6677. All right, well, I don't even know what it is, so I'm going to tell you what it is, all right? I'm going to tell you that the closest number that's a Fibonacci to it is 4181. And we missed 6677 by 2496. All right? Now, you can see what I did in the second step. I'll just go through this with you with the answer here, all right, since I don't have the table to help us do it. The closest Fibonacci to 2496 was 1597, and I'm missing it by 899, right? So now I've got to get the closest fib to 899, which of course is 610, all right? And I'm missing 899 by what? 289. And then I took 289 and broke it down because it's not a Fibonacci number. The closest one to it was 233, right? Subtracted that and I got 56. And the closest Fibonacci to 56 was 55, which gave me the 1. So if you check it out, this is the correct answer to that problem, okay? I kind of zipped through that for you to help you get it done. So you can see that even if we use a very large number, we have to develop the Fibonacci table out to that number or close to it to be able to do this problem. But you can see it can be done. It's not a big issue. Okay, very good. All right, what I'm going to, oh, I did want to say one other thing before I forget, okay? Did you notice that all these numbers here, I mentioned it already, are non-consecutive Fibonacci numbers. If you were to look at a table and see that some of these Fibonacci numbers were right next to each other on the table, what would that tell you? You haven't done the problem correctly, right? We want non-consecutive numbers, okay? So when you do the video quiz I'm going to walk you through next, which is video quiz 6, okay, you've got to realize that you don't sometimes have to work these problems out. If I gave you some answers that could be choices, you just have to make sure that the choices are all non-consecutive, all right? So we'll see that here in a couple minutes. Okay, so what I have to do now is stop the share on this screen with you, okay? So I'm going to stop it right now, and I'm going to bring up the video quiz number 6, okay? So that is right here. So I will share that, and now you are seeing the video quiz number 6. You may have printed it. If you did not, you don't need to. Just jot down what you think are the correct answers to video quiz 6, okay? And then what we will do is what you have to do is text them to me so I can give you a grade on the quiz. So let me move this down a little bit. Here are the first few terms in the Fibonacci and Lucas sequences. This first problem uses Lucas. It says to evaluate this expression right here, okay, when n is equal to 8. Now, let me explain something to you. Notice the parentheses around this term that I am circling right now, right? Those parentheses are around the whole thing. They're not around just the subscript. So what you've got to do this problem correctly is to put the 8 in for the n, get the subscript, but you don't square the subscript, do you? What you do is you square the actual Fibonacci number. So plug in the 8, rewrite the sentence, in other words, do this, rewrite the sentence, f sub n minus 1 all squared plus f sub n plus 1 all squared. Plug in the 8 in here and in here, get the subscript. Once you've got the subscript, what do you have to do? You have to figure out what Fibonacci number it is. Then you square them. So I'll give you a minute or so to do that right now. So go right ahead and do that. Now I'm going to assume that you have found each of those answers, and what you want to do, you square them and you add them together. And notice the choice there. There is a choice there that says that the correct answer isn't shown. So one of those 3 up above is either the correct answer or I didn't put the correct answer there. That's what you have to decide. Now, if you've not finished this problem, you certainly may come back to it by backing the video up, all right? And you can look at it again. So let's go on to question number 2. Here are the few terms in the Fibonacci and Lucas sequences. This time I'm dealing with Luca numbers. When n is equal to 12, I would like you to tell me what the answer should be for L sub n minus 1 added to L sub n minus 2. So go right ahead and do that now. Get the subscript first, get the actual Luca number, then add them. Now I'm going to assume that you've gotten the correct answer, and if you have not had time, just back the video up a little bit and it'll give you more time to decide to get what the answer should be, or put down what the answer should be. Let's go to question 3. Here are the few terms in the sequence that is generated just like the Fibonacci sequence is generated. Now, can you tell me what the next 4 terms would be? How's the Fibonacci series generated? Add the 2 previous to get the next, correct? So use that system to determine the next 4. Now I'm going to assume that you have been able to do that problem. Again, if you need more time, just back the video up and give yourself a little time. You actually can freeze the video if you want also, and you can obtain what the answer should be. Okay, now this is primarily the reason why I wanted to do this video quiz with you, is because I want you to think before you do this problem. Here are the first few terms again in the Fibonacci's and Lucas. Which answer correctly expresses 1102 as the sum of non-consecutive Fibonacci's? Now I'm going to tell you right now, the answer to A, the answer to B, and the answer to C correctly add up to 1102. All the numbers in each of those answers are Fibonacci numbers. All right? But you don't need to go through the whole process of figuring out the answer. You can just look at the 3 answers that are there, and you can make sure they contain no consecutive Fibonacci numbers, no numbers that are next to each other. So take A, look at it. If there are any Fibonacci numbers in there that are next to each other in the table, it can't be that answer. They have to be non-consecutive Fibonacci numbers, right? Look at B, look at C, and if none of those answers are correct, you will pick choice D. So go ahead and do that. Now I'm going to assume you've had time to finish that one. Back it up if you need more. Back up the video if you need more. Now here's the same question basically again, except it's with Luca numbers. Okay, all those are Luca numbers in A, B, and C, but some are consecutive and cannot be used. All right, so look and see which one, A, B, or C, to see which one is the correct answer. And if it isn't A, B, or C, you will pick D. So go ahead and do that one. Now I'm also going to assume that you have been able to answer this question. So that's the last question on this video quiz. Okay, so we have covered quite a bit of material involving Fibonacci numbers. We are about to go on to do some more material. I'm going to stop this video here so it's not so much to upload to YouTube and it's not so long. So I will be bringing up for you the next video shortly. So take care. I'll see you soon.